Welcome to Math 2210. We'll be looking at some problems from Chapter 8. Now, Chapter 8 is our introduction to what are called confidence intervals. So, for example, what do we mean by a 95% confidence interval? Now remember, we construct a confidence interval from a random sample. We hope that the true value of our parameter is contained in our confidence interval, but by, well, essentially bad luck, it may not be. To be 95% confident means that if we repeated the process, that is, if we took repeated samples, 95% of the confidence intervals that we constructed would contain the true value of the parameter. There's no such thing as 100% confidence unless if you have the time and the money to study the entire population. The ideas on this page we'll be coming back to as we do some specific examples. Now, our first example. I'm going to be switching from this screen to the calculator screen. I haven't found a good way with the calculator of doing a double screen. It's just not visible. So you might want to jot down these figures. So suppose our sample size is 25, and we know that from the sample that x bar, that is the sample mean, is 11.5, and s, the sample standard deviation, is 1.3. Let's construct a 99% confidence interval for the population mean. 99% is really very high, probably higher than what is usually done in real life. Okay, so with this information, let's switch to our calculator and let's have a look at it. So a confidence interval, you will first go to the Stat button, and I've always felt that the confidence interval should go under the Calculate heading, but they have it listed under the tests. If you've looked ahead in the book, you'll see that we're going to be doing a lot of what's called hypothesis testing. It makes sense to me that hypothesis tests would be under the third category, but they do put confidence intervals there also. So the trick is you have to be real careful that you select a confidence interval rather than a hypothesis test. So let's go over to tests. Okay. Now we want the confidence interval. Notice that number 7, we see our first mention of an interval. Let me page down a little bit here so you can see a few of these. Now, number 7, the z interval, we won't be doing that in this class. Let me explain a bit. The z interval is used when you know the population standard deviation. Okay, a population standard deviation. Well, think about it for a minute. If you don't know the population mean, how would you know the population standard deviation? Well, in statistics classes several decades ago, before we had such essentially the good technology we have today, everything had to be done by hand, and it's a lot easier to construct a z-interval. So most instructors would do the simpler z-interval, then they'd tell the class, okay, you know what, we probably aren't really going to know the population standard deviation in any real life problem. So now I'll show you how to handle it when you don't know it. And next they'd move to what's called the t-interval, also called the student t-interval. We're just going to deal with realistic problems where that will be the case. So, you know, of course we would, you could either type in number 8, or you could scroll down to it and we have our t-interval. Now we can do it by inputting data. That would be like if we had a list of numbers, or we can do stats. Let's just go to stats because that's what I gave you for this problem here. So stats, okay, enter for that. And okay, so we have to enter our sample mean, which is 11.5. Okay. We go down and enter our sample standard deviation. We have to know our sample size. So I put in 25 for there. Now for the confidence level. For this problem I said let's do a 99% confidence level, so that would be 0.99, and we can go down to calculate to get our answer. Now what you see there is the confidence interval. It goes from like approximately 10.8 to about 12.2. So our confidence level is 99%. So what we're saying is that if we repeated this process multiple times, about 99 out of 100 times, we would expect the population mean to fall within the range that's calculated. So that's pretty good. Now notice X bar is right in the middle of that. You'll see some problems where they'll talk about a point estimate. The point estimate is X bar, and it falls here right in the middle of that confidence interval. So if someone asked you, give me a number, what do you think the population mean would be? Well, your best guess would be that it would be equal to the sample mean, 11.5. But you know there's a lot of uncertainty, so this interval accounts for that uncertainty. Now in real life, sometimes you might look at the confidence interval and go, man, that's too big a range. If all I know is it's between 10.8 and 12.2, I need to narrow it down more. Well, the practical way of narrowing it down would be to increase the sample size. Now that's going to take time, maybe even money, but that would be the way to go about it. Okay, let's go back to our PowerPoint and move to another problem. This time, I essentially have the same type of problem, but I gave you data rather than statistics. Suppose a college takes a random sample of students and records their ages and years. Let's find a 90% confidence interval for the mean age of the population. Where I gave you data there are 15 data points listed. Okay, you might want to pause, jot down those numbers, and let's go to our calculator. Okay, I'll quit this screen. I want a confidence interval, so I do stats. But this time I have to enter the data, and remember under edit number 1, that's where you can put in a list. We'll put it under L1. So I'm just going to first type in these numbers. And you can do the same thing if you got a calculator with you. 17, 19, 25, 23, 18, 19, 22, 43, 18, 19, 18, 20, 21, 22, 17. Okay, I have a list 15 numbers long. That's what I wanted. So hopefully I didn't make any mistakes in entering. So let's quit this screen and let's go to stats. And as I told you, the confidence intervals are not under calc, but they're actually under tests. So we want to go down on our tests, and as I told you, we won't be doing a Z interval. We'll be doing the T interval, number 8, if you have the same model I have. And this time we're going to enter data rather than stats. And okay, so last time someone used this, probably me, they had it under L1, so that's good. If not, remember you can pick that down here, this portion of your keypad. Frequency is 1. In other words, each number I typed in, let's assume that there was just one of those. And confidence level for this one. For this one I said let's do a 90%, if I remember right. And let's go down and calculate it. Okay, our mean 21.4 is also known as our point estimate. It gives us our sample standard deviation, and is 15. And so notice 21.4 would be in the middle of this confidence interval that runs from about 18.5 to about 24.3. Again, if you wanted to tighten this confidence interval, if you needed a better estimate, well then instead of having 15 points sampled, you probably want to go out and get more data. All right, for the next example, we're going to do a proportion. So go back here. A proportion. 7 out of 15 is a proportion. Suppose that 7 out of 15 of the previously sampled students voted in the last presidential election. Let's find a confidence interval for the population proportion. So all you need to know is that X is 7, N, number sampled is 15, and we want a 0.95 confidence interval. So back to the calculator. I'll quit this. I go to the Stat button again. Go over to Tests, but this time we're doing a confidence interval for a proportion. So we're going to want to go down to where the confidence intervals start, and we're going to want to start looking for a proportion. Okay, notice here we have a 1 proportion and a 2 proportion. The theory in the book tells you that there are always z-tests for proportions, and of course we just have 1 proportion. We have 7 out of 15. So let's go up, and here it's A, the 1 proportion z-interval. And notice how easy it is to enter this. Remember, it was 7 out of 15, so 7 out of the 15. And confidence interval, what did I say? I said 0.95. Calculate that. Now that is p hat. That means a proportion. The point estimate for the proportion is 0.466, and that is the middle of our confidence interval, from about 0.2 to about 0.7. If we wanted to tighten that interval again, we'd want more than 15 points. By the way, that point estimate, the 0.4666666, we didn't even need to do all the statistics for the point estimate. The point estimate would just be 7 out of 15. That is 7 divided by 15. It's all the statistical theory you need to get the confidence interval. But the point estimate is just a simple arithmetic calculation. Now I have one more example I want to do, and it's because earlier in the week I received several emails regarding a problem like the next one. Suppose out of 94 randomly selected cars, 83% of them have a CD player. Let's find a 98% confidence interval for the true population proportion. Okay. So we have 94. We know that N is the 94, but we need the value of X. Well, it just tells us 83% of them have a CD player, so we can do that calculation. We would do 0.83 times 94, and if you do that, you get approximately 78.02. Now, obviously, out of 94 cars, 78.02 of those couldn't have a CD player. It must have been that it was 78. So your calculator won't work if you use 78.02. It's 78 out of 94 cars had a CD player, and that's approximately 83%. So you need to do this calculation and round before you go and reach for your calculator. Well, this will be a pretty easy problem to do now, but I'll go ahead and finish it with you just to end this lesson here. Exit again. Okay, want stat. We want to go over to tests even though it's just a confidence interval. And this is a proportion of cars that have a CD player. So one proportion Z interval. So X we determined to be 78, and we knew it was out of 94 randomly selected cars. I asked for a 98% confidence interval this time, and go and calculate that. So the confidence interval is like approximately 74% to about 92% of the cars have a CD player. One final comment or two to wrap this up, to remind you what a confidence interval is. We took a random sample of 94 cars, found that 78% of them had a CD player. That turns out to be about 83%, which is known as P hat that you see on the screen. But remember, it was only a sampling of cars, and we're trying to figure out what's the estimate for the actual population. Now, when you take a random sample, there's always some error involved. You might find in your random sample that maybe more of the cars had CD players than the whole population, or maybe fewer. That's why we get an interval. We're saying we can't really know the true value of the population unless if we looked at every car in the population. The sample, well, at least will give us an estimate, and that's what this confidence interval is. It's an estimate of what the population proportion would be. All right, that wraps up this lesson. As always, good luck.